Hey guys, it's Mr. Thrasher. This is a video where I'm going to go over our final exam, our mock AP test. Look at the problems, letter A, B, C, and D, and kind of like our past free response practice, talk about the solutions. Now, first, this video might be a little bit different in that I don't know if I'm going to actually write down solutions for each of the problems because you already have the rubric in front of you. Okay, you already took this test, so to speak. So I don't think I'm going to bust out my phone and have the timer going. And I don't necessarily will write down the answers for every little thing, but I'm going to talk about the problem, some key ideas for each of the questions, maybe some misconceptions. In fact, if you see this red star next to a problem, it's because I saw a common misconception as I was grading your final exams, this mock AP test. So how might you use this video? One, the video is optional. If you're like, oh, Thrasher, I'm sick of your videos, you don't have to watch this at all. If you're really trying to have kind of a post-mortem on your AP exam, your final exam, especially if maybe you didn't do as well as you would have liked, what I would maybe recommend is first, have the solutions out, whether you print them out or you just have an extra window open. But I would have the rubrics, the College Board rubrics out, because I might refer to them. I might mention where they're assigning points. And then also, if you can, have your actual final exam out. If you took a couple JPEGs, maybe you just open those up in another tab. If it was in a Google Doc, you could do that. Maybe go back on Canvas, and you should, again, be able to access it there. But let's go through the different questions to touch upon some of the key ideas. Okay, now question one, the qualitative quantitative. All right, this diagram here, you have this container that's filled with this oil, right? That's the whole basis of the problem. You release this little ball bearing, this little ball right here, right at the level of the oil. And then, you know, it describes the situation. It says that they're able to make these measurements where they're measuring the mechanical energy that's lost with respect to the stiffness. Okay, and there's going to be questions interpreting this graph, interpreting equations, etc. First thing, all right, a lot of people, and I'll mention this again later on, a lot of people didn't recognize that the ball is starting at rest and it's being released right as it's touching the oil. So some responses later on, they mention like, oh, the ball's falling, then hits the oil. That's not really the case. It's not the case where the ball is speeding up, bam, and then starts slowing down. The ball is released from rest right where the oil is. And therefore, depending on the stiffness, the ball might be speeding up a lot, or it might very, very slowly, not speeding up much at all. Okay, so this was never really a scenario where the kinetic energy of the ball was decreasing. The kinetic energy of the ball was either increasing a lot, going faster and faster and faster, or increasing very little. It starts at rest, and maybe because the oil is super sludgy and thick, it's now just barely moving. Okay, so the initial kinetic energy is 0. The final kinetic energy is some non-zero number. I guess maybe it could be 0, right, if this was a solid ball, a solid glob. Anyway, let's talk about question 1A. And here's the star, because about a third of you did not get this question right for the same reason. This says give a physical reason why the curve in the graph would not reach the vertical E-loss axes if the scientists had taken data over a broad range of temperatures. A lot of you, about a third of you, gave me answers explaining energy. That is not the right approach. They're talking about this line reaching the y-axis, and it's a little confusing, but if it's reaching the y-axis, you shouldn't actually be looking at the y-axis, you should be looking at what that means for the x-axis. What does that mean if we're right here? I mean, you know, there's some energy loss, but that means there's 0 stiffness. This is a question really asking, why is there a physical reason why you'd have 0 stiffness as a measurement for this graph? And the points were assigned for recognizing that oil is always going to have some stiffness, right? Unless there's no oil, you're always going to have some type of resistance happening. Okay, so the answer to this question, ironically, or maybe surprisingly, even though they're mentioning E-loss, it's not really talking about E-loss. It's asking, why does it make sense that this would end up being 0? And in real life, you can't have something with zero stiffness. Even water has some resistance, right? Even alcohol, even the thinnest material, the thinnest liquid, so to speak, you could think of has some resistance to it. So that was the idea for A. It was not really asking about energy. Okay, now for B, it says as S increases, E lost approaches a maximum value labeled E max on the graph above. Ooh, I wish I copied and pasted this over. So here's that line, and it's approaching, right? It's approaching, not passing, not even hitting. It's approaching this line, E max. The question is asking to describe what E max value must be equal to. This is the problem that used to be an equation, derive an equation. Okay, and it said derive an equation with M, with D, and with any constants. You know, constants like G or K or something. This was a tough problem. Okay, the idea is, again, looking right here, this object, this ball starts at rest. Does it begin with any kinetic energy? No. Relative to the bottom of this beaker, does it have gravitational potential energy? Yeah, that's the energy it has in the beginning. You can't lose more energy than you started with. So I assign points, and remember, if you saw my last video, I had to tweak this rubric a little bit. So I assign points for mentioning, for saying that this E max must be equivalent to the initial energy or the total energy. I gave a point if you said either of those things. It's the initial energy of the ball or it's the total energy of the ball, because that's the maximum amount of energy you could use. And then I gave another point, or in fact I gave 2 points for this, if you made it explicit. What's that energy? That's the gravitational potential energy. You didn't need to write an equation, but the original question, this was the right answer, m times g times d. Okay, that's the energy that the ball had to start out with. Okay, you could argue that maybe my grading is a little unfair since I tweaked it. That's possible. Okay, but that's how I assigned it. If you just said, oh, it's the maximum energy, to be honest, if you didn't go any more in detail, I very well may have given you 0 points because, you know, they want an application to the question. All right, they don't just want you to say, oh, well, at max, okay, max and E is energy, so it's the max energy. That's what it is. Right? That's not really meaningful. Just like if they have those, like, you know, you choose one of the options and you choose this one. Okay, they don't really ever give points just for saying this. They want you to apply some reasoning to it. Okay, but that was question 1B. Let's get into 1C. 1C says one of the scientists is trying to represent a relationship between the oil stiffness and the mechanical energy lost. Okay, so they're trying to now essentially come up with an equation for this graph, because this is a graph of mechanical energy lost and stiffness. So now they're trying to write an equation for mechanical energy lost and stiffness. C is a constant. Remember, pretty much ignore the constants unless the question's really trying to nudge you to analyze that constant. Okay, but if they just say there's a constant with appropriate units and then they just kind of move on, you can pretty much ignore it. So it's asking, another scientist points out that this equation cannot be correct. Give 2 reasons. I gave essentially 1 point per reason because C was out of 2 points. Okay, and they have some guidelines for how to give points. I was looking for unique responses. They say the term independent statements. So if you essentially gave me 2 reasons, but they're really the same thing, there's a chance maybe I only gave you 1 point. Again, I don't know for sure how they would have graded that. Maybe College Board would have been super lenient, but some people said like, oh, this graph is asymptotically approaching some vertical value, some y value. There's reason 1. And then reason 2, you said this equation doesn't match the graph increasing by less and less and less. Okay, I saw that a handful of times. That's kind of the same thing. So if you said that, it's likely I just gave you 1 point. Okay, one way to answer this is showing that this equation doesn't match the graph. This is a quadratic, right? You would have something like this if I had energy versus stiffness, because E versus stiffness squared, that's some quadratic. So a common answer, well, this equation doesn't give the graph that's shown. There's 1 point. And then you could have wrote another point a couple different ways. Maybe you mentioned like this equation would pass right through this E max, and obviously in this graph it's not passing through E max. Or maybe you said this equation would have some values right here, and the graph doesn't have values right there. So there were certainly multiple ways to get those 2 points. Again, if you only got 1, it might be because I thought your 2 reasons were really the same reason. Okay, and that was a misconception right there. So try your best if it's asking for two reasons to give two unique, two independent reasons. It could either just be like graph analysis and equation analysis. This equation gives this graph and that doesn't match. Or it could be like a physics analysis. Again, the oil should never have zero stiffness, or it shouldn't be approaching the maximum, that potential energy that the ball has. Okay, let's keep going. Let's see. Oops, sorry. I'm right here. D. It's saying, oh man, another attempt to model the ball's motion. This time writing an equation for time. They wrote an equation. T is proportional to 1 over S. Again, ignoring this constant. We don't really need to worry about it. You guys knocked this problem out of the park. This was an easy couple of points. Okay? You pretty much all got it right. You said, well, wait a minute. If the stiffness is getting bigger and bigger because it's in the denominator, that's saying the time is getting smaller. It's taking less time. And that doesn't make sense. If I drop a little ball bearing in water, a very small S thickness, versus I drop it in honey, well, dropping it in honey with a bigger S, that should take more time. So this equation is not plausible. You didn't get any points just for marking this. You really had to describe what's going on. And, that was pretty quick. Thickness is in the denominator. That's saying that as S gets bigger, T gets smaller. That doesn't match what we know about, thicknesses, stuff like that. Okay, so D, you guys did a nice job. For E, again, I have that misconception alert star right here. All right, this was another problem that I had to tweak. Originally, this line wasn't drawn, and you were asked to draw this graph. Draw it, it gave you this. And it said draw delta K versus S. Okay, now where did I assign points? 1, I assigned points for saying that you agree. This graph is correct. This was the graph from the solutions. This graph is correct. And then an explanation for why this graph is correct. And part of that explanation had to include this. You might think that's kind of arbitrary that I'm including a point or that I required a point for it not hitting this vertical axis. But again, this was a hard problem. Historically, people did not get all the points. So I wanted to make it a little tricky to kind of match the old version of the test. Okay, here's why I discussed this diagram in the beginning. A lot of people gave an explanation that this graph is wrong because it should be something like this. And you gave explanations about like work and friction and the change in kinetic energy. But a lot of you were making the assumption that this ball was dropped from some height and then it hit the oil. So it's like losing kinetic energy. That change should get bigger and bigger because there's going to be a bigger loss in kinetic energy when it hits thicker oil. But that's not the scenario. That's not what's happening. The ball starts with 0 kinetic energy. And if this was super thick, let's say this oil was infinitely thick, this was just a block, it would just never start moving, right? If I release it right at the level and it's so thick the ball never moves, well, that kinetic energy would be 0. And look, when the oil is super thick, that kinetic energy never changed. So tough problem, definitely a tough problem, okay? Most people, and this is even going to like global, all right? A College Board releases statistics about how people did on average for everyone who took the test, and this was a low-scoring test question, this E question here. Okay, so it's not this green value. Maybe it would be if you had a scenario where the ball was moving at a high speed and then it impacted the oil, but that's not what's going on here. This graph is correct. The thinner, the less stiff this oil is, the more this ball is able to speed up as it travels through. That means you have a bigger change in kinetic energy. Okay, it is concave up. I'm not really going to get into why. You could prove it. You could use like work energy theorem stuff to prove it. Maybe link in a kinematics equation if that force was constant. The old question didn't. Actually, they did. They did require a point for concave up. Anyway, if you can't figure out why it's concave up, let me know. I don't want to get into it this video because I know there's a lot of problems to go over. That's the end of question 1. Let's talk about question 2. For question 2, there was just parts A and B. This was a paragraph length question or a paragraph free response question. Again, just because it's a paragraph free response question does not mean there will only be one question. There might be a part A and a part B, so make sure you double check, okay? So you have this block, you have it going up an incline, and it says there is friction on this incline. Oh man, so our classic like KE equals UG, that might not be applicable here because there is friction, and you knock the block up, it slides up, it's eventually going to slide back down. Okay, for the first question for A, I copied the diagram right here so you could see it. Originally, this was a question I tweaked. Originally, it was drawing two free body diagrams. One time on the way up, another time on the way down. Okay, and you got 2 points for making these correct. I think you had to adequately show that on the way up, friction would be acting this way, and on the way down, friction would be acting this way. That was actually the core of the original question, that the frictional force is changing direction. I just had, was this diagram correct or not? This maybe was a little easier than the original, but this normal force should be perpendicular, and it says that the block was just struck. It was just hit right in the beginning, and then the block's moving. You're not constantly pushing up the block. And a handful of people made the implication that the block was also being pushed down. And that's not the case. That's not what the problem describes. So make sure you read this problem, the scenario, carefully. It's given an initial kind of jolt, a strike, and then the block on its own is going up, stops, and back down. Okay, so there was that one. That's one most people got full points. Nicely done. Okay, this was the actual meat of problem 2, the actual paragraph length response. Okay, you could have approached this a couple ways and still could have gotten full points. You could have analyzed it by looking at forces, net force, therefore acceleration, therefore speed, therefore time. Or you could have approached it from an energy point of view. Okay, kinetic energy to potential, back to kinetic energy, but there's friction. Friction's doing work that's taking away energy. Therefore, the kinetic energy is less. Therefore, the speed is less. Therefore, the time is less. Okay, you could have done either of those. First, 1 point was given just for writing like a coherent paragraph. All right, so pretty much nobody got a 0 on this problem if you tried it, because if you wrote just some coherent paragraph somewhat addressing this problem, you usually got 1 point. Okay, now the solutions, the rubric has a couple different ways. They start out by describing the forces, and they use Newton's first law. On the way up, let me give a brief synopsis. On the way up, if I'm looking at like up and down the ramp, on the way up, there is both friction and there is the component, ooh, right here. This is mgx. And there's a component of weight acting down the ramp. So when the block is sliding upwards, there are two forces acting down the ramp. The net force up or down the ramp, there's a net force down the ramp of these two, okay? Going back down the ramp, ooh, this is a tough problem. Going down the ramp, of course, we still have weight acting as mg, and therefore, of course, we still have this mgx right here. Here's mgx. But now, friction is pointing up the ramp. So here's one way to explain it. And this is a tough problem. This is definitely a paragraph length response. I love this question. I want to steal it and put it on my forces test next year. On the way up, there are two forces acting down the ramp. On the way down, these forces, mgx, look, I'm going to circle them, mgx and friction, they're in opposite directions. There's more net force going up, because two forces are in the same direction. So there's more net force going up. Well, by Newton's second law, that means there's more acceleration acting up. Here, there's less net force. Therefore, by Newton's second law, there's less acceleration. And then, AP assigned 2 points for discussing velocity and speed. Because here's what a lot of you guys did. You said, okay, there's more force, there's more acceleration, therefore, what's the right answer? This one. It's going to take more time to go down. And that's a great way to approach the problem. Okay, you hit with some big facts. But College Board, for this problem, they assigned 2 points for essentially linking acceleration to velocity and then time. And that's what the majority of you didn't do. A lot of you kind of stopped here. You went straight from acceleration to time. And that's kind of tough to do, right? How do you just go from how fast or the rate something's accelerating to the time it takes. Usually you need like a constant motion acceleration or equation or some further explanation. Okay, but 2 points were linking like, oh, if you have less acceleration, you're going to have a smaller change in speed. Oh. If you have a smaller change in speed and you're traveling the same distance x, you're going to have a smaller time. You could have used equations. They actually didn't require it. Okay? So a lot of you guys got 3 out of the 5 points. You missed 2 points linking speed to time. Now, that doesn't mean you should all of a sudden think, oh man, okay, I got to always talk about speed. You guys did a great job on this question. If you talked about forces and acceleration and then time, you did exactly our strategy. Hit me with the big ideas and then move on. If you have more time, maybe you could have gone back and talked about some more of these details, okay? But if you got 3 out of 5 points, that's great. Remember, the goal, get half the points or more. So if you said, okay, there's more net force, therefore there's more acceleration, therefore there's going to be a shorter amount of time on that way up, okay? Beautiful. You didn't get all the points, but you got most of the points. You could have replaced this force and acceleration by talking about energy. You had to be a little careful. You had to be clear. Okay, you start off with only kinetic energy. You end with gravitational potential here. That's on the way up. There's friction, so you're losing energy. But then on the way back down, you have this UG back decay, but there's still friction, so you're losing even more energy. So this K after is less than the K before. And then once again, oh, okay, so I have less speed at the end than I do in the beginning. If I have the same traveling distance and I end up with less speed, it must mean that I wasn't traveling with, or I wasn't having as much change in speed, therefore the time would be more or less than before, okay? So there were a couple ways to answer this question. Look over that rubric. It's tough, they list a whole bunch of stuff, but a lot of you guys did a pretty nice job on it, okay? Keep that strategy, keep that idea, that mindset, that approach for the College Board exam. Okay, that's the end of me analyzing the final exam questions. Okay, hopefully that clears things up. Hopefully you understand maybe a little bit better why you lost points, why you didn't. Again, you could email me. Just recognize it might take time for us to set up a time to discuss your individual test. Okay, but if that's something you really want to do, if you really debate a question, let me know and we'll figure out a time in the next week. Okay, that's it. Thanks for watching.